give you a little idea of what I'm going to try to cover today. Pretty much going to revolve around the drainage planning service that we do. We're going to talk about why you start with a drainage plan. We're going to go into a few of the drainage fundamentals. Some of the technology that we apply after we analyze those situations. Take a look at a case study, actually a golf course here in the area. We're lucky enough to have Mike Barton from Burning Tree in Connecticut, where we've done a plan and currently doing some work up there right now. We're going to take a look at, once a golf course does a drainage plan, how do they want to attack the installation phase? Should it be contracted, should it be done in-house? And then lastly, what you should expect once you've done the planning. But first thing is why you want to start with a drainage plan. Our niche in the industry is giving clubs an alternative to completely reconstructing a golf course to solve drainage plans. So what we have tried to develop over the years are systems that allow an existing golf course to go in, solve their drainage problems without closing that golf course, work on specific areas of the golf course. If drainage is the major primary reason, that the thing they want to solve. Now, obviously, if there are playability issues or aesthetics, then you may have to be taking a look at a total renovation, bringing in an architect and moving dirt. But what we typically do in the industry is when it's not, those aren't the objectives, when the objective is mainly just to, if you're happy with your golf course, you're happy with the way it plays, it's maybe a classic old golf course and you don't want anybody to get in there and mess with it, but you want to solve the drainage issues, that's where we can give you an issue. Every club has different types of objectives. We work with a lot of projects that for tour golf courses. The tour gets us involved in tournament projects. So it may be a golf course that wants to be able to provide professional tournament conditions after heavy rainfalls. It might be a golf course that wants to, maybe a classic golf course that they want to be able to get carts on the golf course and they don't want to build cart paths because the size of the property, they feel like a cart path would ruin the aesthetics of the golf course, yet they want to be able to offer their members a way to still get out and get on cart traffic. So it may be about revenue. If it's a municipal golf course, it might be all about just generating more revenue. So we help the club to define what the objectives are and what parts of the golf course. So in many cases, we may come in and do 1 or 2 holes only, and we only put on the plan what that golf course is concerned with. But one of the things I've always talked to superintendents about when they're trying to decide whether to do a drainage plan is how it's a tremendous aid in their ability to communicate with their green committee or their owner about what their issues are. Once you have, and in your case as green chairman, it also will aid you in communicating with the rest of your committee or the memberships there at the club. So that one of my favorite stories is several years ago we were down in Florida. A club was interested in hiring us. They had heard about some of the things we had done down there at some other clubs, and we were called in for a meeting at a committee's chairman's house, and there was about 6 people in there. And actually I had my contractor with us that day, and we walked in, and the committee started talking basically amongst themselves and really arguing amongst themselves about what was the best way to solve the drainage problems. And every person on that committee was speaking about what they thought needed to be done and how it needed to be solved. And it literally went on for over a half hour. Finally somebody looked at us and they said, well, what do you guys think? So we got around and we did a drainage plan for them, and I think it helped that club a lot because it gave them something very specific to argue about after that. So but it does help define, it at least gives your committee something that's on the table to discuss, because until you have, a lot of times until you have a drainage plan, the variation of what the different committee members think is the cost or the scope of the project can vary so much from one committee member to another. So we're not exactly right. When we finish a plan, there's still a lot of it's a very subjective thing because we're trying to meet these clubs' objectives. So if we had the same golf course but two different memberships, the drainage plan would be different for the two different memberships. So it's not an exact science, but it does give you a starting point, the committee a starting point, and the membership a starting point as to something to discuss and go forward. But it does give specifics. It gets very specific. In fact, there's a plan here I have if anybody wants to take a look at one from the Burning Tree project. But it will detail the size, the type of the system, the length of the project, the man hours. One of the big things it does is it gives the club a tool to judge their progress. So they're able to, once they start on the installation phases of a plan, they're able to go through that and relate to and can go through their membership and annual reports and show them how far along they are. And typically, clubs always start with their worst holes, their highest priority holes, and it's obviously easy for the membership to see the results on those holes. But it also gives the membership a way to project to the membership how many more installation phases are left and money to be spent and so on. I am going to get into a little bit of fundamentals of drainage, but we're not going to go into a large amount of detail, but to give you an idea of the basic thing we do is we try to analyze the different types of drainage problems, and the main classification of drainage problems are really two. You have surface and seepage. We're going to get into collection and transportation in a second. But surface water would be defined as anything where you have puddled water, streaming water, water that's on the surface that can be collected through an open inlet. Seepage water are those problems where the surface water is gone. You no longer see puddles or streams, but you still have either a mowability problem, a playability problem. It's trapped in the profile, and that type of water requires different tools than the surface water does. But it's these defined, and every hole in different parts of the country, and actually different parts of the same hole, can have different amounts of percentage-wise of how much of that particular issue is a surface and how much of it's a seepage issue. And because of that, we design the systems individually. So it's always that combination of getting the right combination of surface and seepage drainage tools to solve the problem. But the seepage water, for instance, there are three types. You can have water from lack of velocity. So that's the only type of water that is surface water at one point on the project, but it turns into seepage water before it's able to get to a collection basin, a surface collection basin. Because that type of water was surface at one time, it does give us some options sometimes in collecting it before it becomes seepage water. The other two types of seepage water are water from a high water table and water that comes onto the property as a hillside spring. The water that comes onto the hillside as a hillside spring was surface water at one point, but never when it was on the boundaries of the property. So that it has to be collected as seepage water on your property because it entered into the property before it got to your boundary line. Give you an idea, here's a fairway, an area that, and I'll show you compared to this next picture, but this is seepage water from a lack of velocity. So this area has some slope, there's some watershed, there's this concentration of flow in the area above it. In most cases, the areas that are affected with poor drainage, they're not receiving any more water than the higher areas, but the reason that they're a drainage issue is because they're collecting water from more square footage or more watershed above. So it's that concentration of flow that causes the problem. And the water that was trying to make it to that inlet down there in that fairway never made it because it had to travel too long of a distance before it could get there. Here's a picture of water from a high water table. There's really no movement of water, but the creek or the stream that's on that golf course has so little elevation change between the fairway grade and the creek that you have a constant saturation problem. So it requires two different types of solutions. The other classification of those surface and seepage, each one of those problems, surface or seepage, is broken down further into whether it's a collection or a transportation problem. But we're not going to go into a whole lot of detail on those, but all drainage plans will be a combination of surface and seepage tools, and all transportation systems will meet proper drainage principles. This will give you an idea of some of the surface collection tools that we have. We've developed this. This is a patented basin in that it has, if you'll notice, it sits in a geotextile bag. So from the surface, it looks like any other basin, but most drainage basins that are used in golf courses are built just like you would build something in a parking lot. So they're designed for the surface water to go in through the surface, but when that water gets trapped in that profile outside of that basin, for instance, the seepage from lack of velocity, it has no way to get in through the sidewall. Well, with this basin, it not only collects the surface water, it's put into a pit of sand and it collects the seepage water through the sidewall. So it is a surface water basin, but it also collects seepage water. Now, we build two different types of units. These basins are built for different depths of seepage water, depending upon what type it is, and we build these things in kits, so that we can build them anywhere from 2 to 8 feet deep. We have another type of basin that's built for surface collection of streaming water, and those can be built in kits that can in modules, and they build them as wide as whatever the water stream is. So what we do is we go into a golf course without moving dirt. We identify contours, existing flow contours, and then we build the basins to match those flow contours so that we can collect the water the most efficiently. This will give you an idea of the seepage collection portion of it, and these are the trenches that would be replacement for what typically has been used in the industry as perforated pipe and gravel. We're going to get into that a little later, but we don't use gravel, we always use sand as a backfill, but these seepage fields are built around all of these basins in these different areas, and they're designed to expand that influence, that collect the ability that basin will not only collect seepage water now, but an entire seepage field will be built around those basins, brought into that basin, and then the basin will transport that water out of there by one of the transportation means that we'll take a look at. Give you a little idea of the technology. The use of geotextiles is primary to what we do, and we use geotextiles because we can build a technically correct system that meets all the proper seepage and drainage principles much easier than you can with gravel and perforated pipe. And without getting into a lot of details, a comparable technically correct system with gravel, the standard of the industry for years has been to dig a trench and you put gravel in that trench directly next to the native soil. But in engineering, if you're building a dam or a highway, to use gravel as a seepage engineer where you could have loss of life if a dam collapsed. They don't just put the gravel next to a native soil. What they do is they build what's called a multi-layer system. So you have this gravel, and then you have the sand, and then you have the native soil. So it is the same principle. It's all based upon seepage and engineering formulas that were developed back in the 40s. It's called the Terzaghi formula. The USGA adopted this formula when they rewrote the green specs in the early 90s, and when you send off your green specs to be tested, you'll see the D85 and the D15. So what they're doing is they're taking a look at those particle sizes in greens construction. But the use of gravel in a greens construction, what they're doing is they're matching up that 15th largest particle in the greens mix to make sure that it's not going to enter the void that's created by the gravel. Well, as you can imagine, you all know that your greens mixes are huge in size relative to native soils. So if you took that native soil that was out there in your fairway and you wanted to place that gravel directly next to that native soil, your 15th largest particle in the native soil would be way too small to be matched up to that gravel. So as a result of that, we use Sand is the backfill. The sand matches the opening of the geotextiles. The sand matches the particle sizes of the native soil. So we're able to build technically correct systems very inexpensively relative to having to build multi-layer systems. Transportation systems. Once the water has been collected, whether it's surface or seepage water, and it's in the system, then it's a matter of transporting it to the relief. The commonly used system in the industry, obviously, and still dominates 99% of all drainage installations that go in, are gravity reliefs, because that's, in general, what people are always going to grade pipe downhill and let it flow out. What we look at, though, is we don't just look at grading pipe, and because we get in most projects that, I shouldn't say most, but certainly a large portion of the projects we get called into, people have already been in there before and tried to repair them. When we see drainage projects not work that were used previously, in most cases it's because of improper reliefs were chosen. So what we do is we know that the relief is the most important part of the drainage system. You can spend all kinds of money on a seepage system, you can spend all kinds of money on USGA green, but if that relief that green is draining to isn't open and free flowing, if it doesn't have the ultimate relief of the airspace, 100% free flowing airspace, then you're going to build a storage compartment and not a draining situation. So what we look at in transportation system is, can we build a system that has self-cleaning velocity? So every gravity system should have enough grade, enough slope on the pipe, and different size pipes will determine the slope because of the friction of the pipe. But will it have enough grade on that pipe for it to move the contaminants through the system? So seepage water is you're collecting water in a stable system. That water that goes into that system has no contaminants moving. If it does, then your system's destined to failure, so we'd be back to gravel contaminating. But surface water is always going to have contaminants. When you have an open inlet and you have silt or debris, clippings that come into that system, it's going to enter that transportation system. If there's not enough velocity of that water moving through that pipe over, and that pipe's laid too flat, too close to zero grade, those contaminants are going to settle out, and over a period of time your system's going to fail. A lot of times in the industry what happens is, because there really aren't a whole lot of alternatives, even if those grades are very flat, golf courses or contractors will tend to just go ahead and put in the gravity pipe anyway. In our case, if we can't meet that basic principle, then we look for an alternative, and that's really why we've developed these alternatives over the years. So the first one that we developed, it kind of gave us a lot of publicity, was when we developed a siphoning process back in the late 80s. We commercialized it in the early 90s, but it became the first system where you could install drainage without the need to grade the pipe. So the piping could actually go into an ungraded trench, or you could actually go up over a mounding, equivalent to 1 atmosphere or 33 feet. It works off atmospheric pressure driving the system. In the end, the water still has to go to a lower elevation. We're going to look at a graphic in just a minute. But the piping that connects the collection point to the release point can go up over mounding. So it gives you a lot of alternatives. It gives you an alternative, particularly on flat golf courses, but it also has applications anywhere where it's difficult to grade pipe, like a mountain course where there's a lot of rock. But it gives you that opportunity to put pipe into a place where you otherwise could not go to this selected relief and get a self-cleaning velocity of gravity pipe. The other types of transportation system that we've recently developed over the last few years, irrigation-driven pumps. Now, we've always built a lot of electrical pumps, and sometimes, so if we're on a flat golf course, a coastal property, something like Seminole, where the first hole we went into was their third hole there, was about a foot above sea level, and we told what we would do is put in one central pump, and then we would bring siphons from all these different directions, but those siphons would replicate the airspace of that pumped elevation. But we might have 30 siphons going into a pumped elevation, but it's like you only have to maintain one pump and one electrical point, but it's like having 30 pumps out there. The other ones work off just the airspace. So the pumps, though, themselves still, if you had that type of property, you still had to get at least electrical out to that one central pump. Now, a lot of times siphons don't need any pumps at all, and you're just using them to get to an adequate relief without having a great pipe. But just just getting that electrical even to that one pump sometimes became a very large part of the cost of the project. And we developed these irrigation-driven pumps. These are pumps that allow you to put a pump anywhere on your golf course without having to run electrical to that site. So you use the energy of the irrigation system to drive that pump, and it can save a tremendous amount of money in a large project. Most projects are combinations of gravities, siphons, and pumps. Certain parts of the country, we might be typically 99% gravity systems. California, for instance, out in Northern California, we do a tremendous amount of work, a lot of rolling property there. And we do lots of projects that have no siphons, no pumps. But as you get into flatter properties or other kinds of difficulties, particularly when you get into flood zones, flood plains, you get into more of these combinations of these systems where you use the gravity, siphons, and the pumps. This will give you a little idea about just a graphic on how the siphon system works. You'll see the system when it's flowing. What we do is we initially we connect the system to the irrigation system. So the siphon pipe is connected with a valve that is normally closed, but it's open at the time of priming the system. You can create a vacuum in a pipe in one of two ways. You can put a vacuum pump on it, or you can displace all the air by filling it with water. The cheaper and the simpler ways, what we do is we connect it to that irrigation system, prime the system, and that creates the vacuum that allows the atmospheric pressure to drive the system. Then the patent lies in how we build the systems to control the elevation so that it doesn't siphon itself dry. But whenever the water, you'll see on the system where it says system flowing, whenever that system's always trying to get to equilibrium. So it's trying to get to where the atmospheric pressure is pushing down on both ends of the system at the same point, so that there's water in the pipe but no water flowing if there's no water coming into the system. So and whenever water is in the basin higher than the control elevation, that atmospheric pressure starts to push that water to the relief again. So it can be at equilibrium, you get a rain, the water comes up, starts to flow, pushes it back down until it reaches equilibrium and stops waiting for the next rainfall. And that's what you see on the right where it says system at rest. So it reaches that equilibrium, and at that point it is at rest and waiting for the next rainfall. Just to give you an idea of what a siphon looks like, this is actually one on number 10 at Eastlake, but you can see that's what we call a 4x6 siphon. We're collecting seepage water in 4 feet deep. Now, the depth of the seepage water is always different, and that's why you go through the planning process. Again, depending upon what type of seepage water it is and what the objective is on a particular fairway, with the grass type, shade, soil type, will determine. Typically, we work between 2 and 8 feet deep. And the big thing that these systems do is these allow us to get this depth of drainage without having to grade out of those depths with an excavator. And because, again, our niche is working on existing golf courses. If you were going to grade to the particular relief we were going here and collect that water 4 feet deep, we would have had been in there with an excavator done. We would have done a tremendous amount of damage to the golf course. In this case, we were able to collect it 4 feet deep. The piping, as you can see, is actually run about 20, in this case probably 20, 22 inches below grade, just with a trencher. So we're in there with a trencher instead of an excavator, a lot less damage, a lot less disruption, a lot less cost, but still gives us the ability to build these deep seepage systems around the basins when they're needed. Little stuff about the irrigation-driven pumps, as I mentioned, it allows you to put the system in without having to run electrical to the site. The disadvantage of the system is that in the north, where if you're blowing your systems out for the winter, those systems aren't going to be operational during the winter. So that's always a factor in the design process. How does that fit your club's objectives? What are you trying to do in the off season? But they do have a lot of advantages, and they do have a lot of application. They may not be for every situation, but they certainly are a tool that we can use. Let's give you an idea of what one looks like. And these come in different sizes. This is what we call a mini IDP. The two basins on the right there are the same basin that we use in a gravity relief or a siphon relief, and it's what you saw on the ground there. It has a geotextile bag. So the one is a 4-foot deep basin, the other one's a 6-foot deep basin. But in this case, it all fits into that structure, and these pump out small amounts of water. Now, we build them in for different applications in much bigger sumps. Mike has one that actually he has quite a few of them on the hole that we're doing there, but one of them that pumps 250 gallons a minute, and it's obviously built in a much larger sump, about a 6-foot sump. But depending upon what, in his case, it's a hole that's in a floodplain, and we're trying to assist with getting that water out of there after flood events. These smaller, what we call mini IDPs, are more about being able to collect the water from a seepage field, give it an airspace so that that seepage field can work effectively and drain those seepage fields. The key is always, though, the depth of drainage and controlling the water table, and that's what these systems, siphon systems, or any of our this ability to get these depths of systems is all about, is going in and creating a V in that water table, and then determining the spacing so that we know how those V's overlap, and where we can get the control so that you can grow turf, you can maintain the golf course, get the golf course out there and play without plugging up balls. We're going to look at a little bit about Mike's drainage plan. There's burning tree. A lot of times when we do these things, we choose a club where we've already gone through all the installation phases. Not unusual for us to, once we've done the plan, to work with a club for 3 to 8 years as they install and do the installation on that plan as it fits into their budgets and so on. But we're just in that starting phase with Mike, but with it being a local golf course, so we're going to project some of these numbers based upon past experience. But his golf course was built in 1962. It was a Hal Hurley design. I asked him if it was okay when I did this slide if I said he had a long history of drainage problems, and he gave me permission to say that. So it's a golf course that it's a very difficult property. It has some low-lying holes in the floodplain. You get some runoff of the Merritt Parkway. If that wasn't hard enough, then you got some very difficult rock. And after I did the plan, I called the contractor and told them that if we got the project, it would be the hardest project they ever did. And so far, it's living up to that pretty well. The first phase of it, we came in last year. We even got another surprise we didn't expect. Some of you all may, I actually asked a fellow here this morning if he'd ever heard of, Jim with the USGA, a term called corduroy fairways, which I've been in for a few years and I've never heard of. We got into their 10th fairway there, and we're digging down and we run into a tree. It's about 12, 14 inches, and get the chainsaw out and cut it. And so we get underneath that, and there's another tree laying the opposite direction, about the same size. So we get the chainsaw out and cut it. There's another one underneath that. So we finally found out that apparently when they built the golf course in this particular hole, they did it on the perimeters of the fairway to provide structure, being in a floodplain along this creek. I guess it was pretty ingenious, actually. I guess the hole wouldn't be there if they hadn't done it, but it makes it pretty tough to put drainage in. So we're battling through. It's been a little bit of a slugfest, but we've met our objective in the fall, which was to get the transportation systems in with some siphons and pumps running, so that we've got much better control of the water table. We're now up there just starting today, putting in the seepage collection fields that will be going into each of these to increase the collection. To give you a little bit of idea of how any drainage plan works, and we've got his up here. When we went through this process, he and I walked every hole in the golf course, and of course some clubs will only have 2 or 3 holes that they want to deal with, so whatever it is that the club wants to address. But we will identify every area of that golf course that needs to be drained in terms of location. We go in, we determine the type of system that we're going to have, the depth of the system. So all these things that we just talked about previously, about whether it's a surface issue, a seepage issue, how deep that pipe needs to be, pipe size, the way to transport it. And then we go in and we calculate the parts cost. We have formulas to calculate labor based upon past history of every component that we put on the plan. We know how long it should take a certified contractor to put it in. This is one of the things we look at. We're going to talk about the options of doing projects in-house. But one of the big things is how fast can you move dirt, different ways that dirt are moved. A lot of times in drainage projects, courses are using plywood and shoveling it up into Cushman trucksters. Sometimes people are using front end loaders. Our contractors, we've developed a method where we move the material with tarps, and we can move tremendous amounts more dirt, 4 to 5 times more dirt per man hour, and with very little damage. So these systems are very simple, but they tremendously increase the speed. And these are systems, these tarp systems are systems that you can buy for in-house projects also. To give, again, the case study here, burning trees, some of these things are projected as far as the man hours here in just a minute. But the components, we're going to end up at the end of the plan, once everything's installed, we're estimating probably over 200 basins, over 25 siphons, almost 20 pumps, almost 60,000 feet of turf drain, that's the seepage fields, over 12,000 feet of transportation pipe. There will be about 8,000 tons of material moved. That would be the spoils that's coming off and the sand that's going back in. Projected cost is about $1.5 million. Man hours in planning, this is projected, but should be pretty close based upon other projects. When we talk about planning man hours, we're not just talking about the hours it took to do the drainage plan, but every phase of the project, every site that gets installed, I come in and we take that drainage plan and we put it on the ground in paint. Mike's crew goes through, paints out the irrigation systems. Once we figure out where the crossings are, we set the systems up to do the least amount of crossings. But where they are crossing, typically the golf course crew does that potholing, locating the irrigation pipe. And so that when we talk about planning, that's what we're talking about, the overall history of the project or the life of the project. You'll end up with, just before you put a trencher into the ground in each spot, because obviously you don't want to be going in there and tearing up irrigation systems, either electrical or whatever. You have to prepare and make sure that everything's laid out also efficiently so that it collects the water most efficiently. We're very big on angles, and again, won't get into a lot of details, but we don't use very many herringbone patterns because of efficiency. But it's very key to how well a system collects as to exactly how it's positioned across the slope. But projected work days, probably 137 work days for the contractor, almost 10,000 man hours. Mike's crew will probably end up with about 3,000 man hours in it. That is primarily from operating the commercial sod harvester we'll take a look at here in a second, and doing the locating of the irrigation. Now, all these things, if you want to contract those things, that can also be contracted, but it's typically less expensive for the golf course crew to do the things that they're very good at, as opposed to having a contractor. But the projected days that the actual golf course would be closed for this work would be 0. You would have days where those holes are closed that we're working on. We work on one hole at a time, but you're never going to close the entire golf course. And a lot of people want to know is, am I going to be able to do this project in-house? Am I going to want a contractor to do it in-house? Once we've done, the advantage of trained contractors is they have some specialized equipment, have knowledge of these specialized systems. They have these, we've developed these methods to do the least amount of damage on a golf course, and the work typically can be completed without shutting down the golf course. But there are certainly areas where it makes sense to do projects in-house. And after we do the drainage plan, we give you a realistic appraisal of what type of project yours is in terms of the ability for it to be done in-house. And those things are going to revolve after we've looked at the project. Obviously the size of the project, the size of the crew there at the golf course, the difficulty of the project. So as I mentioned, when we told our contractor Burning Tree was going to be one of the most difficult projects they ever did, that's certainly not our advice to the club at that point is if they wanted the golf course staff to do it in-house, our advice then to that committee and that club would be that this project didn't fit into an in-house project. And that's really one of the big things that the drainage plan does for the superintendent or the green chairman dealing with this committee is once we've calculated out this project and we can show that a particular project is going to have 2,000 or 3,000 man hours in it, it gives them something concrete to say, do I even want our golf course crew to be distracted for 3,000 man hours from the other things that they would be doing? So it's a big part of the communication process, having these drainage plans so that you know what you're getting into and you don't get into a project that is above the ability, in some cases, of any golf course to do in-house. Once we've done that plan, we can give you that realistic appraisal. And again, the types of projects, whether surface water projects loan themselves a little more to in-house projects. The equipment's not as critical. The depths aren't as critical. There's just a lot of things that make it easier. But if it has a heavy influence of seepage drainage, chances are that, and it's a large size project, you're probably going to find that you can actually contract it less expensively than you can do the project in-house. Talking about some specialized equipment, this is just giving you an idea of some of the stuff we do. This is a commercial sod harvester that we put on the job. The golf course crew typically operates it, but it gives you the ability to strip sod not only much quicker with much less labor, but the finished project is so much better than going back in with a walk behind handcuff. Sod. First of all, we identify every roll. You cut these the sod strips. We number them so we know which trench it goes back in and what direction it goes back in. So as you know, there are you have different patterns of grass and on a fairway. And if you go in with new sod, that new sod can stick out like a sore thumb for 5, 6, 7, 10 years until it matches. But with this, you're putting that sod right back into the exact same spot, and you have very little visibility. I mean, literally within a few months. But what you really should expect after you do a plan is a plan that will allow you and an installation that will allow you to meet your club's objectives, whether that be tournament conditions after a major rain, just reducing the number of restricted days on cart pass, increased revenue, or healthier turf. The hole that you just looked at that was pretty much a mess in the fall, Mike took that picture for me a week or so ago, so it somewhat recovered, but I feel pretty confident by this summer, particularly after we get the seepage collection in, that it'll be a dramatically different hole than it was before. This is just a quote from an article that was in Golfman magazine a couple of years ago. It said, while the turf drain siphon system easily handles the surface water, Hicks is especially impressed with the system's ability to firm up soggy fairways rapidly. Not only can members get on the course quickly after a heavy rain, they're playing on firm fairways where the balls don't plug. And that's down there at Seminole. Hal Hicks is the superintendent there. But, if there's any questions, I'd be glad to try to answer them if I could.